Good morning, everyone. My name is Madhu. I am from SRIT College from CSMB department. Today, I am explain about the topic of classification of programming languages. Introduction. Why classify understanding the programming languages? These are classifying programming languages helps us to understand their fundamental characteristics, typical use cases, and underlying philosophies. It provides a structured way to compare and contrast different languages, aiding in the selection of the right tool for a specific task and fostering deeper appreciation for the diverse world of software development. There are two major classifications is there that programming languages are mainly classified into low level language, high level language, language. First, low level language. Low level language close to machine hardware, offering fine grained control and high performance. Examples include assembly language and machine code. They require a deep understanding of computer architecture but allow for highly optimized code. In low level languages, there are two machine language and assembly language. Machine language is first machine language. These are using zeros and ones. The execution is fast in machine language. The machine language is difficult to write and debug. Next, assembly language. An assembly language uses mnemonics like ADD, MOV. Requires an assembler more readable than machine language. Next, high level language. Abstract away hardware details, focusing on programmer readability and productivity. Examples include Python, Java, and C++. They are easier to learn and use, leading to faster development times and more portable code. C Java, Python, Ruby, JavaScript. These are examples for high level language. JavaScript is primarily imperative and functional with object oriented capabilities. Types of high level languages: procedural languages, object oriented languages, functional languages, scripting languages, logic or declarative languages. Let's go. Procedural languages. Procedural languages. Imperative languages, also called as imperative languages. Imperative languages focus on how a program operates. They use statements that change a program state, providing explicit control over the sequence of operations. First, state modification. Programmers dictate the exact steps the computer must take to achieve a result. Variables are frequently modified, reflecting the changing state throughout execution. Let's examples. C and Java is examples for programming procedural languages. Next, object oriented languages. Object oriented programming revolves around the concept of object, which are instant of classes. These are different encompass both data and the procedures. Data, also known as attributes, and procedures, also known methods that operate on the data. This operates modularity, reusability, and maintainability based on objects also concepts classes, objects, inheritance, polymorphism. Examples: C++, Java, Python. Functional languages. Functional programming treats computation as the evaluation, mathematical functions, and avoids changing state and mutable data. Functions are first class citizens, meaning they can be assigned to variables, passed as arguments, and returned from other functions. These are based on mathematical functions, emphasized immutability. Immutability definition: data cannot be changed after creation. Pure functions. Functions are always produce same output for the same input with no side effects. Example: Lisp, Haskell, Scala. Next, scriptive languages. Scriptive languages are generally interpreted rather than compiled, enabling rapid development and testing. They are often used for automating tasks, web development, and system administration due to their flexibility and ease of use. Interpreted execution. There are three three types, four types is there in scriptive languages. Interpretive execution. Code is executed directly by an interpreter without a separate compilation step. Next, rapid prototyping facilitates quick iteration and development cycles, ideal for small scripts and web front ends. Dynamic typing. Variables often don't require explicit type declarations, offering greater flexibility at runtime. These are used for automation, web development. These are also used in JavaScript, Python, PHP. Python, JavaScript images is there. Next, logic or declarative languages. Declarative languages describe the desired result without specifying the sequence of steps to achieve it. The system determines the execution strategy. Focus on logic and constraints. Emphasis on what rather than how. Abstraction from execution details. First is SQL, querying database. There are SQL full form is structured query language is a prime example where you specify the data you want to retrieve or manipulate and the database engine optimizes how to execute that request. Protolog. Protolog is their logic programming. Protolog also full form is programming in logic, allows defining facts and rules, then querying the system to find solutions based on those logical relationships. Next, applications. Machine language embedded systems. Assembly language device drivers. High level language app development. AI web development. Scripting web development automation. Game development, mobile application development, desktop software. These are all useful in programming languages. Conclusion. Programming languages vary in level and paradigm. Each type has strength and use cases. Understanding classification helps choose the right language. Each type of language has its own advantages and applications. Choosing the right language depends on project requirements, complexity, and performance needs. Both high level and low level play a crucial role in modern technology. Thank you for listening my few words.